So this one's going to be a bit dense. I'm going to start with the simple stuff first. And then as you go on, you can shut off this video and stop listening to me rambling if you want. It's whatever. And then I'll get more complex. This one's a shout out to Celeste again. I spoke to her earlier. This is a very important concept I hope everybody can understand when it comes to stars. And it's kind of cool if you think about it. I mean, figuring out what rain is. Why is it raining? It's weird. Why is stuff coming out of the sky? Why should it come out of the sky? It's a phase transition. And I have a little graph here. Plasmas, gases, liquids, and solids. And as you go up, the enthalpy means heat. You add more heat, you get things hotter. There's more molecular motion. The stuff changes and it does weird things. So solid, let's use ice as an example for the first three. So you have ice, you have water, and then you have water vapor. And up here, a plasma would be that water vapor completely disintegrating into hydrogen and oxygen gas. And if it does that, it would be called ionized, which means it wouldn't be basically water anymore. It would just dissociate into its parts, hydrogen and oxygen, and all those parts themselves would also be ionized, meaning they would have their electrons ripped away. So it's pretty cool. And to keep it simple, for this talk, I'll mainly go over gases and plasmas. These are two completely independent phases of matter. Imagine there's a wall right here. A plasma is not a gas. A gas is not a liquid is not a solid. You can mix them together, as a mixed phase, but for the most part, they're completely independent. They have different properties. For instance, a solid, if you put an ice cube in a cup, it's not going to fill the cup all the way. It's not going to take the shape of the cup. A liquid will take the shape of the cup, but not fill it up all the way. And if you take water vapor and you put it in a cup, it's going to take the shape of the cup and it's going to fill it up. But if it's a plasma, it's going to light up like a light bulb and it's going to leave the cup altogether. And that basically sums up the beginning of this talk. I want to make sure that people understand that there's completely different phases of matter. And the reason why I wanted to go over this is I had a YouTube commenter say that gases do not gravitationally collapse because gases fill the container that they occupy. Like a 2-liter bottle. If you fill a 2-liter bottle up with Coke and you shake the Coke, the carbon dioxide will fill up the entire container. And if you open up the top of the 2-liter bottle of Coke, the carbon dioxide will escape and the water will remain. The actual product will remain, but the carbon dioxide a lot of it will escape because it will want to fill the new container it is, which is the room that you're opening the Coke bottle in. And I think the YouTube commenter was concerned that they don't believe that gases gravitationally collapse because gases fill the entire container. So how can you make a star a gas giant? How can gas giants exist if gases fill up the whole container? Why wouldn't a gas giant just fill up all of outer space and then keep on going to where, gas giants don't even exist? And that's the problem because they're ignoring gravitation. Gravitation keeps the gas there for the most part. And it loses this gas over time as the star evolves. As well, it isn't that the gases just undergo gravitational collapse. It's not like they're collapsing and forming the planet. What actually happens is a lot of the superheated gas loses its enthalpy. When a gas giant is really hot, after it moves from its hotter stages of evolution and it moves down here, it recombines. A lot of that gas still has a lot more energy, and it does a thing called condense. It condenses into liquid, as well as it deposits into solid material, given the pressures and temperatures are just right. So essentially, it isn't that the gas giant can't gravitationally collapse, because it does some part of that, but as well, it undergoes a phase transition, meaning the gas that the gas giant is composed of turns into solid and liquid material because it loses its heat. The water vapor that's inside of Jupiter or Saturn or Neptune or Uranus, that's going to condense into water. It's going to be raining a lot inside those interiors, given when they cool down internally and they start forming their oceans and turn into ocean worlds. Of course, that's alongside its mass loss when the atmosphere starts dissipating away. And we know it happens because we have various stages of stars that do that. You have the plasmas up here, the really young stars, and these are what I would call population 1 stars, where there are plasma and stars in the visible light spectrum. They're the stars you can see very well. The population 2 stars are the ones that are mostly gaseous matter that no longer have strong visible light spectrums. The material isn't recombining, okay? The reason why stars shine is because the plasma of the star, the ionized material, is undergoing recombination. Now, what recombination means is that those ionized particles that the star is composed of, think of the sun. What's happening is that those ionized particles are gaining electrons around their nucleus, and they're neutralizing. And when an ion gains an electron, what happens is it radiates. It releases some quanta of energy. That's why stars shine. That plasma is turning into gaseous material. And the reason why they shine continuously is because it's a feedback loop. The plasma that's recombining into gas, okay, it recombines into gas, releases light, and then that gas falls inwards into the star because it's heavier, and then it gets reionized again back into plasma. So there's this large feedback loop that's happening inside the surface of the sun. And we can see that through the solar granulation. It looks like, I don't know, kind of like something boiling, like a very viscous fluid boiling, like lava kind of on the surface. But what that is plasma recombining into gas, and the gas becoming plasma again, and it's circulating through the atmosphere of the sun. And these convective cells are just fantastically huge. They're like the size of the Earth. But only young stars can do that. But once a lot of the plasma recombines back into gas again, the star loses its energy, that young plasmatic star becomes a gas giant. And it cools off to where you can't see. It doesn't have a visible light spectrum anymore. It moves into the thermal spectrum. Thermal meaning heat. If you look at it through a thermal telescope where it has some type of infrared detector in it, you can see the star much better. Like the WISE telescope can find a lot of stars that are highly evolved in middle stages of evolution, and they shine brightly inside the infrared detection because that's the wavelength they're looking for of light. So to say the gas giants don't exist because gases can't contract isn't quite telling the whole story. It isn't that the gases just contract by themselves. The stars start out very, very, very hot and energetic, and the gravitation keeps that material there as it goes through its feedback loops of recombination, ionization, and eventually it does so much of that and it loses so much mass that it can't recombine anymore, and it just shrinks. And it becomes a gas giant, a red dwarf, and a brown dwarf, and a gas giant. So that gas still stays there. Eventually, over time, it loses that extra gaseous matter, and then that gaseous matter continues the phase transitions into liquid and solid material, or mostly liquid. So you have the gaseous matter undergoing condensation and vaporization. It goes through these feedback mechanisms. And then it also goes through these feedback mechanisms. This is how diamonds are formed, by the way. The carbon and the methane, I don't know, there's some type of strange reaction that happens inside of like Neptune, where methane gas like crystallizes under extreme pressure and the hydrogen is ripped away from the methane, and then the carbon takes up and connects with other carbon and forms diamonds, and it rains diamonds into the interior of Neptune and Uranus. And that's why we find diamonds underneath the crust of the Earth. And you can find them in kimberlite tubes, because the kimberlite tubes, they had shot up those very, very deep diamonds that were inside the interior of the Earth. But the reason why the diamonds are really low is because before the crust had formed, and the Earth had a very, very thick atmosphere, those diamonds were forming in the atmosphere, and they were raining down into the interior. And then the outer crust started forming and encapsulated all those diamonds. And then, I bet if we wanted to find a lot more diamonds, we would just have to, dig extremely deep into the Earth. I bet you there's a whole hell of a lot of them down there. And even on the surface of the Earth, I don't think they're all that rare. I think it's because De Beers Corporation has such a monopoly on them, so that they can jack the price up real high. But actually, diamonds are pretty common. But anyways, enough of diamonds. The diamond process, I think, is probably gaseous matter depositing directly into solids. So you have that superheated gas undergoing a deposition. And sublimation is like carbon dioxide. If you ever played with dry ice before, dry ice is condensed carbon dioxide gas. And when you have dry ice, it just sublimates right back into gas again. It doesn't even go into liquid form. So that's a lot of material does that in nature as well. And under extreme pressures, I can easily see that a lot of material that's solid on the Earth was at one point straight gas, and then didn't even go through liquid stages. It just completely skipped that phase altogether, just went straight down. And a lot of that happens from population to population 3 stars. It happens around this area right here, past gray dwarfs, Neptunes, ocean worlds right here. That's where the that's where the phase transition happens. And I have two principles here. I guess this one, the phase transition principle, stellar metamorphosis, basically astrons or stars move to lower energy phases of matter as they evolve. And the reason why that's important is because the extremely young stars, see, the astronomers, they sort of think that gas contracts in outer space and then forms a star. That's totally wrong. You can't contract a gas by itself. It has to be an extreme form of matter. Star birth, when a star is born, it's born with a lot of ionized material. It's a very exotic process, stellar birth is. It's not just simple as, oh, you have a big gas cloud and it self-contracts. No. Without a gravitational field being there, a giant gas cloud isn't going to self-contract. The astronomers, I think they sort of lost track of reality with that. When a star is born, it's extremely energetic and extremely dense. I would say white dwarfs and earlier stages of white dwarfs, like down here, condenses the material, extremely hot, extremely dense, and it starts expanding outwards to dissipate the heat and cool. Eventually, it reaches a point to where it's the largest it can get, and then it starts contracting from its plasmatic state, and that plasma recombines into gas, cools off, and it goes through regular stages of evolution. Again, that's also why stars that are bright and hot, it's pretty obvious that they're very young. They're not billions of years old. To say a star that's bright, hot, and shining that has the majority of the enthalpy of a galaxy is very, very, very old sort of ignores the first law of thermodynamics. You can't sustain these objects for as long of a period as you can these objects. And intuitively they knew that. That's why they invented the fusion model. And which is really funny because now they have these experimental fusion reactors like the ITER. They're like, oh, we're going to make fusion happen. And it's like, no, dude. That's not where matter is made from less complex form or less from lower parts of the periodic table to the higher parts. You don't make gold, you don't make silver, you don't make iron inside of stars. The heavy elements, and basically all the elements that are beyond lithium, hydrogen, helium, lithium, or maybe even helium and lithium all onwards from hydrogen, they're made inside of AGNs, active galactic nuclei. It's the core of the galaxy that creates the elements, not the stars. The stars are the end process. Those are formed after the material from the galaxy has been made. I'm not the first one to hypothesize that either. I think it's Victor Ambarsubian, I think he was a Soviet. I don't know. I think he was a Soviet astronomer. But he had proposed that back at the Solvay conference, I think in 1957. He proposed that it's galaxies that create matter, and the stars are just the object to dissipate that galaxy birthing event. Which means AGNs, or active galactic nuclei, are the most powerful events in the universe because they create entire galaxies. The stars, they just take that energy and they dissipate it away. It's the stars that create the life. It's not the stars that create matter. It's the stars that create life, because those are the objects that have the properties needed to create more complex molecules that eventually become things like proteins and amino acids and that kind of stuff. Over many hundreds of millions of years, of course. It's a very time-consuming process. But I just want to clarify that it's not as cut and dry as people that first learn it. It's not as simple as I want to make out to be. But then once you start to get it, it becomes simple. You're like, it's obvious. Hopefully, people can understand this and understand that astrophysics it's pretty easy. As long as you have assumptions that work, it's easy. If you have wrong assumptions and you're trying to force those assumptions to be correct, and you're scratching your head, why isn't this working? Well, it's because you're using the wrong assumptions, and that's why astronomers have a hard time forming planets, because their assumption is that they take the young hot stars and they separate them from the old ones. They call these stars and they call these planets, and they separate them in their minds first. So naturally, of course, they're a bit confused. All right, I hope this video helps out some people to clarify a few things. All right, later.